Morning and happy Friday. My name is Phyllis Newbill. I am the Associate Director of Youth and Community Education in one of several centers within ICAT. Today we're featuring another center in ICAT. A few housekeeping things before we get started. As always, we are streaming this morning, so what we say in here does exist on the internet immediately and will continue to be on the internet afterwards. There are pastries and coffee and tea, so please enjoy those. One of the ways that we are able to justify giving snacks every Friday morning is that we have a sign-in sheet. So as that clipboard comes around, please do sign in because that helps us maintain that. If you are a Virginia Tech faculty member and PDN credit or Professional Development Network credit is helpful to you, make sure that you check in with me. If you're online, good morning. We're glad you're here as well. And if you need PDN credit, you can use the questions link or just send me an email. When you have questions, wait for me to get to you with the microphone so that the folks online can hear you. And in the way of announcements, the AI Ethics and Policy through Applied Theater workshops are starting next Friday from 1 to 4, and they'll go the next 4 Fridays after that. I have a flyer here if that is of interest to you. Student seed grants are open now. They are due on Friday, February 13th at midnight. So if you're interested in those, check out our website or talk to anybody who's here. And any other announcements that I'm missing? Okay, great. Well, we're so glad you're here this morning. We're lucky this morning to have Lewis Hickman with us, who's going to share with us. We love to talk about AI. It's our favorite. It's good. So Lewis is going to get us up to date on his research in AI. Take it away.
That's all that we do now in research. It's just AI. That's what CHCI is now. We were joking about previously. So I'm Lewis Hickman. I'm an assistant professor here in industrial organizational psychology. What do? We take psychological principles, apply them to the world of work. I mostly focus on applications of machine learning and natural language processing applied to assessment, selection, training, and development. I'm also a visiting scholar at Amazon. That means one day a week I work for Amazon and their global hiring science unit, where we mostly are focusing on applications of AI to recruitment and selection. Although I'm not going to talk about any of the Amazon stuff today because I didn't want to get the Amazon lawyer's permission to come talk to you. You might have noticed, and if you haven't, maybe you're living under a rock or you're not on the internet, in which case I'm probably envious of your mental health. But there's been a lot of hype around large language models. You can find big names in machine learning software saying very hyperbolic things about what generative AI and large language models are going to do for the world. And Gartner has even created a hype cycle specifically for generative AI. That's how widespread this has become in terms of importance. And HR is no exception. Human resources, recruitment, selection. Market for generative AI expected to be about $2 billion just in like 6-7 years. So a lot of interest in this space, a lot of excitement. Also, though, a lot of concerns worth thinking about, right? We've seen evidence that large language models are biased and unfair in various different ways, right? They're a predictive model. That means they necessarily inherit the information that's in their data, and that's going to be some stuff that's not always fair. I'll talk about a real-world application very relevant to people at Virginia Tech where we took data privacy and security very seriously. If you're putting in like private or protected information to ChatGPT, I would encourage you to stop doing that immediately since OpenAI now owns that data that you expected them not to be doing something with. Concerns about transparency and explainability, human oversight, all relevant to human resources, and we'll talk some about most of these in this talk. I'm going to first, for people who aren't that familiar with how large language models work, what they are, I'll give you a quick overview of how they work, how they're trained. I think that's useful for just really understanding what they are and what they aren't. If you're growing attached to an AI companion, I encourage you to seek psychological assistance, help, because they're just a bunch of regression models. So I wouldn't let that be part of your life if you can help it. We'll talk about some applicant perspectives and uses of large language models, employer perspectives and uses, and then some of the other fun work that we're working on, including with Ryan McMahon, who's hopped in here. So what are large language models? How do they work? Well, they're generative large language models because they're conducting next word prediction, next token prediction technically. I say tokens, though people don't know what I'm talking about. They think we're at the arcade. So I say words, right? Previous language models were trained on masked language modeling, where the words were maybe in the middle of a sentence. Now it's always making the prediction based on all previous text, predict the next word. So it does that, predicts a word, selects one, adds that to your input, predicts another word, adds that to your input, and so on until either it predicts an end of sequence token or your token limit is reached that you can set. When these large language models make these predictions, they actually create a probability distribution across all possible next tokens. That means every token in their vocabulary they're making a prediction for. Most of those get shifted towards 0 through hyperparameters, and then based on those probabilities, it's doing a random selection driven by those probabilities of what token's going to come next. These models are trained first on that next word prediction. So you give it billions and billions of pieces of text. I think I saw that, wasn't it, the news was Anthropic bought like millions and millions of dollars worth of books that they then scanned in to have their system read and get trained on, and they're just going to burn the books or throw them in the landfill, whatever. They thought it's not worth the $4.99 plus 30 cents that you get on Alibris to sell the used books. So they do billions and billions of examples of next word prediction. So what's that involve? You get the text, you know what the next word is because it's in that text. The model makes predictions. You calculate how wrong it is. You calculate how you would update the model to make it more right. You do that a whole bunch of times and make small updates each time based on a batch of data to try to improve the model's accuracy. Then most of these models today are also trained with reinforcement learning with human feedback. So you might have noticed on ChatGPT, you can give it a thumbs up, thumbs down when it gives you an output. Sometimes ChatGPT will also give you 2 outputs and ask you, which one do you like better? That's training data for OpenAI, but they do this on a very large scale as well, mostly paying people in the global south who they can pay a lot less to do this work and gather a lot of this data. This is also part of what makes ChatGPT such a sycophant. Where it's like, oh, that's a really insightful question. Wow, you're asking just the right questions. And I'm like, just give me the answer. Quit wasting time complimenting me. I got things to do. I don't need that. But that's why it does that. People don't want a negative Nancy. They want positive outputs from the large language model. And so that reinforcement learning with human feedback makes the outputs a lot more useful to humans, but also creates this kind of bias toward kissing your butt. And then you might also, in many settings, use supervised learning, have task-specific data. So maybe you've got coding problems with solutions. In my context, we might train, say we want to create something for automatically scoring interviews. We might do supervised fine-tuning on the labels that we expect for the interview scores. So given a prompt and an interview response, what's the score we expect it to get, and further update the model weights to make that more accurate. You put in a prompt to the large language model. There's also what's called a system prompt. Anthropic system prompt leaked, I think it was last year, but I've got 4 kids, I can't remember. Ryan, that was for you. I was just surprised to find out that system prompt was thousands of lines of information about things that the model should or shouldn't do, tools it can work with, types of outputs it should provide. And really open my eyes to how much detail you can put into a prompt. So that's there before you ever use the model, then you give it your prompt. It's then making this prediction across all possible tokens in its vocabulary. And then you've got hyperparameters that control that token sampling that occurs from that probability distribution. I'm going to focus on temperature and top K as the ones that I think are, well, one, temperature everybody talks about, and then top K is easier to explain than top P. So temperature, people will call it a creativity parameter for the large language model. What it actually does is just skew the probability distribution on these most probable tokens. When temperature is low over here on the left, it skews the probability distribution toward the most probable tokens. Makes it so you're almost certain to get the token that the model predicted is most likely. As you increase temperature to absurdly high numbers, I think it's 50 over here on this side, you're basically getting a random selection now. You got almost equal probabilities of these different tokens. So people will call it a creativity parameter. Really, it's like a randomness parameter. Are we going to take the most probable token, or are we going to randomly select from these top K tokens? Here, this is an example where top K is 4. If we wanted to show top K, this is a crude way because actually the probabilities would change. But top K restricts your sampling to the top K tokens. The tokens the model considered most probable. When top K is 4, you're going to consider the 4 most probable tokens according to the model's predictions. Here it's 3, and then 2, and then 1. So if top K is 1, you're always just going to take that most probable token that the model put out. When you're doing research, say that you want to label data with a large language model, or you want to automatically score admissions essays, if you have top K greater than 1, I think you're basically adding random error to your measurement. Whereas if you put top K as 1, you're making sure that you're getting the token that the model thought was most likely. You don't want random error in your measures in social science. So that's something that I don't have a ton of time to get into today, but just want to point out as well. And then reasoning models. Reasoning models are models, and most of the models now out there are reasoning. They basically talk to themselves before they give you an output, and somehow that makes them better at a lot of things. I'll show a study later where the reasoning models made a big difference. You can work with LLMs in several ways. Chatbots are one way. That's your ChatGPT interface. You put sensitive data into there. It's probably taken, and you've violated your data security protocols that you were supposed to be following. APIs going to tend to be more secure. You're still sending data off to somewhere and hoping that they didn't do anything with it that you didn't expect them to. I like to run large language models locally as much as possible. We have this great resource, Advanced Research Computing at Virginia Tech. Allows us free access to GPUs. I found out I was in the top 60 out of 400 PIs in use of the GPUs and CPUs last year, and a lot of it was running large language model research. Because then I can make sure all my data stays within Virginia Tech's IT ecosystem. It never leaves campus, and I don't have to worry about my data going to somebody I don't want it to. Applicants are using large language models in a variety of ways. I've been quoted as saying, I think it's the end of unproctored testing because of large language models. So if you've got unproctored tests, like say you're letting people do quizzes on Canvas in your class still, and they're doing it from home, I would suggest you don't do that because probably you can use ChatGPT to get a very good score on your quizzes if you do that. In the employment world, there are people selling tools that will apply for jobs for you automatically. They will first tailor your resume using an LLM to a job opening and then apply for it. What does that result in? I've seen people post that they have made a new job opening, and within an hour they had 500 applications, all of which, according to their resume evaluation system, had a high match to the job opening. And they're like, people are like, oh, that's harder than ever to get hired. Well, this is part of why. That makes it pretty impossible to tell who you should and shouldn't hire. But man, these large language models are really good at improving resumes. I had an undergrad in my lab a couple years ago. He was having trouble getting a job. He was a senior, right? He's applying for jobs and just getting no interviews. I said, hey, why don't you take your resume, have ChatGPT improve it, and tell it to revise it for the types of jobs you're looking for. He did that, and suddenly he was getting interviews and got a job very quickly. I said, come to lab and show up your resume side by side, like what it was versus what it is now. The original version looked like an illiterate college student had written it, and the second version after ChatGPT looked like God's gift to corporate America had written it. I mean, it's really impressive. The ChatGPT knows, and a lot of the large language models just know that language that people want that is more desirable and really sells things a lot better. So it can be really amazing for improving resumes. The problem is people are also fabricating information on their resumes and just creating lies from these resumes, because you can have it create a resume from scratch. People might have seen in the news a while back, there was this Columbia student who got kicked out of Columbia for creating an AI that cheated. It was actually, the original goal was to cheat on coding interviews at FANG companies. He posted a video online of him going through the coding interview at Amazon and having this system that was just working in the background and giving him the solutions to the coding problems that he was getting in the interview. Once he posted that online, Columbia's like, oh, it's an honor code violation, kicked him out. He did what any good person does, turned it into a startup, and a couple other students from Columbia dropped out with him, and they've raised a bunch of seed funding for a product that, as far as I can tell, is intended to help people cheat on pre-employment assessments and in other settings. So I don't know that it's going to, I don't think those investments are going to return for the people who invested in the company, but it's a very interesting case study of this, and shows what a problem we have, even when that's a situation where you're live interacting with somebody during this coding interview, but still he just had that working in the background and was able to cheat and pass it, and got offers from multiple FANG companies, turned them down to create this startup. I've done a couple of research studies where we looked at how do large language models perform on cognitive ability tests. These are used a lot in pre-employment testing. It's very similar to like the SAT, ACT in some ways. I just saw that the College Board is banning smart glasses from when you're taking the SAT. Makes sense. You don't want them recording the items. You don't want them cheating on the items. If you're doing things unproctored, here's what it might look like. GPT-4 on a verbal ability test, where you get a passage, and then it says, here's a statement about the passage. Is it true, false, or you cannot tell? It scored in the 95th percentile compared to thousands of college graduate job applicants from around the world. Did bad on the quantitative abilities test. This was a number series test, you know, like 2, 4, 6, 8 blank, what's the missing number? But most of the questions way more complicated than that. So we thought, oh, look at that, it's not that good at math so far. Like, hey, maybe we can still use math tests. Well, I was actually on vacation, I think, and OpenAI released their first reasoning model. It's been a year and a half ago, I think. One kid ago for me. They released their first reasoning model. I was like, oh, I wonder, they say it's better at math and programming. How does it perform on the number series test? Well, the full-size O1 model scored in the 95th percentile on the number series test and the 99th percentile on the verbal ability test. And all you had to do was copy and paste the items right into it, and you don't have to do any fancy prompting or anything. Prompt engineering is not a real job. You just copy and paste the items. It worked. Really concerning. Other researchers had shown on personality tests it does this. So any unproctored testing, there's some non-zero number of people who are cheating with large language models, probably doing really well. I'm going to skip over this in the sake of time. Some ideas for what you might do. You might make sure all your assessments are proctored. You might somehow incorporate LLMs into assignments. Just other things that you might be able to do. I want to get to one particular use of large language models for employers that I want to talk about that's relevant to you all, because you might have seen it in the news about Virginia Tech. But we can use large language models in so many different ways when it comes to recruitment and selection. We can write job descriptions, we can do candidate outreach, we can screen resumes. So Dr. Brown showed up. He's up here where we did some research on using large language models to evaluate resumes. Have some other work in progress, various places on that. We can create test items, so you can use it to help you make assignments, help you grade assignments. This is very, very similar here. Got a project where we have an interactive role player for the purpose of like leadership and management coaching and training with some other computer scientists here at Virginia Tech. I also have a chapter where I showed, you can create multimedia for your assessments. This can help enhance fairness in various ways. On the right left was a realistic version. On the right is a version designed to be in the style of Rick and Morty. We've used large language models, zero-shot, no additional training data to score interviews automatically. When we then create a latent variable model for the interview scores, on the left we have the human scores creating a latent variable model. On the right, the large language model scores creating a latent variable interview model. Those latent variables correlate 0.96. So we had multiple humans rate each answer over here and then average them together, create this human latent variable. Here we just have one LLM do it once. So the effort from one LLM doing it once gave us almost the exact same thing that we got from having multiple humans read each interview response. We don't have to worry about them getting tired, about them forgetting their coffee, spilling their coffee on themselves, right? Having these different things that cause fluctuations in their attention and ability to do these ratings. The large language model is just going to keep doing it. So here's the one I wanted to spend at least like 3 minutes on. Some of you might have seen in the news, Virginia Tech is now, well, for several years, undergrad applicants to Virginia Tech write 4 short essays as part of their application around the theme of ut prosum, that I may serve, our motto. Historically, we've had 2 humans score each one of these essays. The most recent years, we've had around 60,000 applicants. So you've got 4 essays per applicant, 2 human scores per 60,000 applicants. You got to collect about 480,000, I think, if I'm doing my math right. I got 4 kids, 2 jobs, I can't always remember. 480,000 essay scores in a matter of a few months. Because of this, Virginia Tech was like later to make decisions than all of our peer institutions, and so we were losing out on applicants. We weren't getting some of the people that we wanted to come to school here because we were so slow in scoring these essays because it's such a logistical nightmare to do that. I think it was my first year here as a professor. This is year 4. I saw this email. It's like, hey, anybody in the Virginia Tech community, staff, faculty, alumni, friends, anybody with a heartbeat, will you help us score these essays? And I emailed them like, hey, I'm not offering to like score the essays per se, but I'd love to investigate, could we use AI to reduce some of this labor that's required? This past summer we announced, yes, now the essays are going to be scored once by the AI that Dr. Hickman developed and once by humans. And that's what we've done for this application cycle. The 4 essays scored 0 to 3 each, so you get 0 to 12 score. When it was 2 humans, if the humans disagreed by more than 4 points, they'd bring in a 3rd human. Now with the AI, if the AI and the first human disagree by more than 2 points, we bring in a 2nd human. So we still have the human there. We're kind of seeing, does the human agree? Because sometimes the humans make mistakes. We've seen cases where they just put in zeros when it didn't make sense to put in zeros, or there's other types of mistakes, right? Some of these people doing this are doing it for 40 hours a week for multiple weeks. I would throw my computer out of the window, or maybe myself if I had to sit and read admissions essays for weeks nonstop. I wouldn't be able to do it. So how does this look? The large language model scores agree with humans better than they agree with each other. The 2 human scores in historical data agree with each other within 2 points, the sum scores, about 89% of the time. The LLM does so about 92% of the time with both of the humans. The large language model scores correlate with first-year GPA better than the average human scores do. 0.11 versus 0.07, just from these, that's 480 words maximum that students or applicants are allowed to put in. And the group differences are very similar to humans with the exception that Asian applicants score a little bit higher. What was the impact this year on we've made offers for the early decision applicants. We were able to put those decisions out 5 weeks sooner than previous years because we've reduced this burden. We estimate that it saves about 8,000 hours of work a year. In addition to predicting student performance better than the human ratings and agreeing with the humans better than they agree with each other. I was told by the Vice Provost of Enrollment Management, basically if we don't get bombarded with FOIA requests for our AI essay scores, he's going to consider this a complete success in terms of how it's gone this year. I'm ready, Phyllis. What's some other fun stuff I'm up to? We need to figure out something that we know really well for supervised machine learning scoring of assessments, but we don't know for large language models so far, is how to de-bias them effectively, enhance their fairness. So doing some work on how we can de-bias large language model scores, mainly through pre-processing methods when we're fine-tuning large language models. So edit the training data to enhance fairness. Looking at how what are the aspects of structure in these rating processes that we should have in the prompt for the LLM that really help and make a difference in fairness and validity. So like in the admissions essays, the humans use a rubric to grade those essays. The large language model gets the rubric in the prompt. And so we have it grade on the same criteria that the humans are grading on. A cool project at Amazon where we have an AI interviewer. That'd be a lot of fun. A project with Ryan McMahon here where we have a large language model after-action review facilitator considered the single most important event in training by the military. We're using large language models to help them scale that up and use it more broadly. And then a fun project, actually, if you're available at 10:30, come over to the Graduate Life Center. I think that's the building right next door. We've got a project on trying to develop tools and co-develop tools with educators to help support educators on assignment design, making sure that your course is secure against LLM misuse, and just any other ideas that we have for helping instructors in this situation that we all find ourselves in. So thank you all for listening. Thank you to my many great collaborators on these works that I don't mention because there's too many of them. And thanks for braving the cold and ice this morning.
So thank you so much, Louis. Let's get going with some questions.
Hello. As somebody who's old enough to have witnessed the evolution of computers into database systems and things that can produce reports that summarize vast amounts of data, I'm kind of struck by the sort of step forward that was made with that, and then people, taking the ability to do that and making better decisions going forward at that time. So couldn't we look at the evolution of AI at this point as, okay, we've got this now massive tool, which in effect summarizes the same inputs that people are processing as you represented manually with the application reviews. So given that, how best can we use that facility going forward, and shouldn't we be teaching students about that?
Clarification then, teaching them how to use large language models to help summarize information?
No, I'm talking about given the ability to summarize that information, that gives you, that liberates, one would hope, an ability to do other things or to be able to orchestrate large amounts of information, like an order of magnitude or more than you used to. So what can we do with that,
Like teaching students how to work with LLMs in order to make those things happen?
How best to leverage the ability to use LLMs?
Yeah. Well, and what's so tough about that, right, is it's changing so quickly.
That's why I asked the question.
Yeah, I have a colleague at Amazon who just everything he does is just Claude code, and he just has multiple Claude code instances, do things and fight over it, and then, okay, here's the best solution out, and that's what he runs with, and you see folks I think it's the head of engineering at Claude and other places, or Anthropic and other places, saying they don't write any code anymore, they just have their agents do it all. I don't think that subject matter expertise is going the way of the dinosaurs. I actually think subject matter expertise is more important than it used to be. And so I think that, but then how do you tell 19, 20-year-olds, yes, this investment in time and energy and late nights is worth it. You can lead a horse to water, can't make him drink. But I really do think that subject matter expertise is more important than it was before, because we have seen some examples in the literature where in really complex tasks, AI assistance widens the performance gap between novices and experts, because the experts can just capitalize on it and use these tools, and the novices are floundering when it doesn't do everything for them if they're using AI that way. So I really think subject matter expertise is still vitally important. And then if you have that, it's pretty easy to work with AI, I think. So I'm a big believer we still need to do the subject matter expertise, and then if you can find ways to use AI to support you once you're an expert, I think that's great. But then the concern is people can rely on it if we don't design our education in a way that prevents them from doing it. They can rely on it instead of learning this expertise that we're hoping to impart in them, and I think that's the concern and challenge for education. So it's a non-answer answer, I think, to your question, though.
Good morning. Thank you. This is very broadly super interesting. I know you're covering a lot of different things about LLMs here. But as to the hiring part of things, what are you seeing from the equal opportunity employment side of things and fair hiring practices? Because this raises a lot of concerns with that, right? I mean, we have a lot of regulations about how people are hired, what you can say, what you can't say, who can make decisions about things. How is this feeding into that? Are we seeing I know that regulators tend to be way behind the curve when it comes to technology, and there's AI is even worse. What are you seeing in that sphere, if
Well,
anything?
people who were concerned about it, and they've all been removed from the EEOC over the last year and a half. The people in the current EEOC are not concerned with what we've traditionally been concerned about with discrimination. They're concerned about people like me getting discriminated against, which just doesn't, it's just not that widespread. Yeah, that's what right, makes sense. The Trump administration assigns the administrators to the EEOC, and what are they concerned about? Anti-white discrimination. They're not concerned about all the other types. They even dropped a bunch of lawsuits, I think, around people with disabilities that were in place, because sometimes it's the EEOC really supporting and spearheading those. So it's a big concern problem right now. They're also pushing for the end of the Uniform Guidelines on Employee Selection, which was developed in 1978 to help codify some practices around like best practices for assessment and selection design. What have I done? I've published multiple papers on how do we de-bias supervised machine learning models. We're now concerned about that from the large language models the same way. How do you help minimize what's called adverse impact, differential selection rates across groups? How do you make sure that you're only assessing relevant information and not relying on things like demographics? So the paper with Dr. Brown here, we recommend, hey, you're using LLMs to evaluate a resume. Delete the name off the resume before you give it to the LLM, because we know that there are human biases from names. The LLMs could potentially have the same thing, but just delete the name. It's very straightforward, right? Like, get rid of the name. But then there still might be other signals of demographics in there. So it's something I'm very concerned about. There are not, we always investigate it when I'm involved. But a lot of what's happened with machine learning and now large language models in workplace assessment has been computer scientists, and no offense, or data scientists go, hey, we got this tool, we can assess people with it. And then they do stuff that like is not defensible at all, but applicants can't necessarily find out because it's all hidden how it actually works. IO psychologists then go and get involved, and they go, hey, we probably shouldn't like do things that are illegal and include those in the assessment. So it's a big issue because so much of it is so opaque to applicants and even to the organizations that hire these vendors selling these products. But at least I know when I'm involved, we're always checking, what's the adverse impact like? What's the bias like? What can we do to bring that down? How do we make sure we're only assessing relevant information and taking that very seriously? But it's a bigger issue. Yeah.
We are at time. So I want to thank, I know we can continue the conversations. Please stay and chat as long as you'd like. There's pastries still and some more coffee, so enjoy that. Thank you so much for sharing your work with us. I think I have more questions than answers, but I'm glad to have better questions. Thank you all for being here this morning. We'll be back with more next time, and see you next Friday. Have a great weekend.